Cool. Is that working?
Great. Thanks. So I'm Jacovella-St-Louis from Ecere, and I'm also the co-chair of the OGC API tiles and the OGC API coverages standard working groups. Next slide, please. And basically today I would like to talk to you about the relationship between cloud native formats and how they can fit within the OGC API framework or family of standards and draft specifications. So I see two ways that the two can work together. So on one end, the cloud native formats like cloud optimized GeoTIFF, GeoParquet, and COPC and Zarr, they can be the backend for what in the OGC API common is called a collection of data. So basically, yeah, it can be a efficient storage either for locally on where the API is located, or it could also be a way to bring in data and offer additional functionality on top of data that's available from affordable cloud object storage. So that's one aspect. The other aspect is those cloud native formats could actually also be the output of these OGC API specifications. So for example, in the OGC API data delivery specifications like coverages, maps, and features, we could have conformance classes that say that you can negotiate cloud optimized GeoTIFF or Zarr, for example, for the /coverage endpoint, and those endpoints could support all the HTTP range requests, so you can have efficient access to your data. Next slide, please. So what's the advantages of this? So from the backend perspective, what these cloud optimized formats provide is they provide the ability to the organization of your data to do efficient subsetting and downsampling so that you can focus on a specific area of interest, and which usually also corresponds to a specific resolution of interest. So that can power these conformance classes that we have in the OGC API specifications. For example, OGC API tiles is really all about that, about overviews and tiles following the 2D tile matrix set standard. And in OGC API coverages, there are conformance classes for downsampling, the scaling conformance class. There's also a subsetting conformance class. In OGC API maps, we have the width and height parameters to control the output resolution, and also a way to subset the data using the bbox or subset query parameter. And OGC API features, there is a planned simplification extension, which will allow similar functionality for vector data. So basically, this provides an organized data storage to make these possible. Because if your data is not organized this way, it can be very computationally. It doesn't provide the efficiency that these conformance classes are supposed to give. So to be able to have these in the backend really enable these capabilities and make the data a lot more usable for large and high resolution data. Then for the output format, it's simply that you can use the usual approach to accessing cloud native formats, but the backend can actually be an OGC API. So the clients don't need to know anything about the OGC API specification, really. They can just directly access the items, the coverage, or the maps endpoint the same way they would access any other deployment of those cloud native formats. Next slide, please. So what do we need from the specifications perspective to make this possible? For the backend, there's nothing to do at all because it all happens behind the scenes. So these cloud native formats just make all this possible. They make it easy to implement those efficient ways to access a specific resolution and area of interest. And for the cloud native formats output, I think what we need in the OGC API specification is to define specific conformance classes for these cloud native formats. Another thing that might also be useful is to advertise the particular tiling scheme that was used to generate those cloud optimized formats. For example, if the tiles and overviews follow a tile matrix set, that could be advertised. And this could be done outside of the format itself, for example, in the collection description endpoint. Next slide, please. So that's pretty much all I had to discuss. So thank you very much. If you have any questions, feel free to reach out to me by email, or I'm also on the Gitter. And there is one related discussion, which was specifically on the topic of cloud optimized GeoTIFF on the OGC API coverages. That's issue 93. But I think the same idea about making these output available applies to Zarr and to the COPC and even to GeoParquet. And also there's in the testbed 17 geodata cube API, we did discuss this, the output as cloud native format. So please have a look at this testbed 17 geodata cube API engineering report. Thank you.
Thanks so much, Jerome. Yeah, and with that, that's a wrap. We really want to thank all of the sponsors, Cardo, Planet, and Development Seed, as well as the bronze sponsors, or whatever they might be called. I don't know. Did they have medals for them?
No medal colors this time. They had names. I think those were the supporters.
Yeah. So thanks all, and also thanks to all the presenters and attendees. This has really been a great turnout. I was really. This is a great job, Chris, on organizing this, and thank you to OGC and Nadine. I think this has been a great event, and like I said before, I'm looking forward to going back and revisiting some of the videos and seeing some of the ones that I hadn't seen. Did you have any closing remarks, Chris?
Yeah, just OGC. I want to thank especially Jonathan and Greg and Pavia, yeah, sorry, who have been doing all the behind the scenes stuff to make this all happen. And thank you, Matt, for moderating this last session and giving a great stack overview. I think the overviews were really great. And yeah, thanks everybody for showing up. And yeah, this has been super awesome to see. And there's videos are starting to get posted on the YouTube channel, and I think we'll hope to get most of them up soon. And yeah, share them broadly with everybody who couldn't make it. But yeah, thanks very much.